All righty. I'm gonna kick it over to Kayla or Bob.
I'll take it over. My name is Bob Chen. I'm a professor and interim dean of the School for the Environment at UMass Boston, and on the Stone Living Lab team. We have with us Rebecca Shore, Kayla Bradley, Kirk Bosma, and the other Rebecca Shore, Joe Christo, also from the Stone Living Lab team. Thank you so much for joining us this evening. We're really excited about coastal surge investigations. This is a sort of initial discussion and thinking about how we'll all work together on looking at flooding in and around Boston Harbor. And I want to start the evening with a land acknowledgement. So I'm just going to share my screen here and play this here.
Our creation stories help us understand who we are, how we came to be in this place, and what our responsibility and role is among all of the other inhabitants, beings, and species of that space.
We've been here for thousands of years. We're still here, and we will remain here.
There's a reason why many Indigenous peoples will start with those stories. And there's a reason why folks that support power, domination, and control will try to discredit those stories and that knowledge.
A true land acknowledgement is working with the people of that land and asking them what that means for them, for that place. Really, the value system of how we're operating and how we're living, it's so embedded in all of us that it's really hard to imagine a world outside of it.
Nothing is ever static from an Indigenous perspective. Things are always moving and changing and evolving and adapting. So land acknowledgement really is a process. It should not end with just we here whose land we're on, but think deeply about what that means. That means that all of us on this land are benefiting from the displacement, removal, the murder of people who came here before, understanding that we aren't the ones that necessarily created that disaster. Yet we are here in this lifetime with a responsibility to do something about it.
So it's really good to keep in mind that different temporal perspectives and different perspectives. The Native Americans were here 1,000 years ago. The harbor looked very, very different. We've put a lot of buildings and we've put a lot of fill in and changed the coastlines of the harbor. And it's actually most of this fill that is vulnerable to flooding. And so we are now in a short period of time thinking about rapid sea level rise and climate change and its effects on Boston Harbor and the neighborhoods around Boston Harbor. And also in the long term, how we will continue to adapt and think about long-term solutions for our relationship with the ocean. So again, thank you very much for joining us tonight. We're really excited to kick off coastal surge investigations. A little bit this is an initiative from the Stone Living Lab. If you haven't seen the website or heard about the Stone Living Lab, we are a multiple diverse partnership of city, state, federal, National Park Service, nonprofit Boston Harbor Now, university, UMass Boston, and many other partners that have input and opportunity for working in and around coastal resilience issues in Boston Harbor and beyond. And we think about, can we adopt nature-based solutions or nature-based approaches to our adaptations at multiple scales, both spatially and temporally. And can we think about maximizing and optimizing the co-benefits, including, we're not just focused on protecting from wave number one or the big storm that's coming this winter, but how can we adapt the coastline so that we can optimize our use of it, for recreation, for education purposes, for interaction, and think about our adaptations at sort of multiple design scales. So I don't have any sort of slides to talk about the partnership, but we do science experiments and measurements in and around Boston Harbor, physical measurements, modeling of the harbor. You'll hear some about that tonight. Chemical measurements, biological monitoring, and we engage with the people and the communities and the organizations in and around Boston Harbor who have interests in a variety of ways. So you might be coming as an individual, you might be part of an organization, you are part of a community and a neighborhood, and you might have a personal and hopefully evolving and growing relationship with certain shorelines around Boston Harbor. Coastal Surge Investigations is the third community science project that we've initiated through the Stone Living Lab. The first one was beach profiling. We enabled folks to go to their local beach with 2 sticks and a string and measure the slope down the beach from the parking lot or seawall down to the water, and make a profile of that every month and before and after storms. And in the chat is a story map of that. We took 274 profiles or something like that. And Mark Borelli is a scientist a coastal geologist, coastal geomorphologist in the Stone Living Lab. And he is using all that information to understand where the high energy change is expected and where it's not, and how sediment moves around the harbor. The second community science project was intertidal monitoring of biodiversity of algae and invertebrates. And there's great timing. The story map of this project in and around Boston Harbor, going into the intertidal, again, sort of monthly, and actually installing temperature loggers at the low tide and mid tide levels so that we could compare temperature and see how temperature and biodiversity co-varied. And we found at some of the very hot July seasons, we had 120 degrees on some black sun-facing rocks that if we can measure that with a temperature sensor, we know that organisms are running away from that. And so with this sort of multiple eyes, multiple perspectives, looking at processes in and around Boston Harbor, partnered with the Stone Living Lab scientists, we can learn more about all of the places and spaces and shorelines of Boston Harbor, and also get some really insightful questions and observations from all of the eyes, the community scientists in all of your places. And so our scientist for this project, Coastal Surge Investigations, is Kirk Bosma, and he will be giving us a little primer on why coastal surge is important and what he's doing and how your work will interact with that. And then we'll sort of end with we need your help in designing how we're going to measure the horizontal and vertical extent in your sites that you choose for surge, which comes generally in the low pressure times, big storms. And we don't want you necessarily out there during the storm, but we want to get evidence of the high levels, like what's behind. Okay, Rebecca Shore is only one now. Behind Rebecca Shore has a king tide flooding event, and we want to know how extensive that is, and when that is, and where it is, and how it differs around the harbor, even at the same event. So again, really want to get to know you all and get your input tonight and through the project. So we'll just start with introductions, and you can say your name and where you might want to be measuring flooding surge, and if you're with an organization, you can sort of name the organization, and maybe just 3 adjectives that describe you. So people have described you as. So people have described me as busy, energetic, and sometimes funny. And again, I'm Bob at the School for the Environment. So we'll start with Esteban.
Hello, sorry, just make sure that your phones are in good. My name's Esteban. I go to school at UMass Boston. I was in the military. I did Coast Guard for 4 years. So I really have a bond with the water. I am currently working, well, as an intern at a nonprofit. And I guess 3 ways people have called me is, I'd say spontaneous, energetic, and I'm sorry, I feel like deer in the spotlight are in the headlight right now. I would say,
You're in the
I
headlight.
guess, yeah, my bad.
That's fine.
I guess I can't even think of the third adjective. I'm sorry.
Perfect. Thank you so much. Ed.
Hello, can you guys hear me? My
Yes.
microphone is okay, great. No, my battery just died. My name is Ed Yu. I'm a science instructional coach at Acknowledgement Academy. I think the 3 words are dad, caffeine, and scuba would be like my identities.
Wonderful.
Yeah.
Caffeine and scuba means early morning diving.
Yeah. Yes. And the area you want to study, I guess, is I think there's a site near the Carson Beach. I forget the exact site. So that is a site that's closest to where our high school students would be studying. And can I pass it to Nick, who is
Sure.
one of the science teachers? Sorry, Nick.
Yep.
Hi everyone. There's my camera. My name's Nick. I'm the AP Environmental Science teacher at Codman Academy. So Ed is my supervisor. So same site. And 3 words to describe me, I guess, thoughtful, quiet, and someone who likes being outside.
Awesome. Thanks, Nick. We'll go to Aaron.
Sorry, I always have a hard time clicking on the microphone button. I'm Erin Kane. I'm a program manager and ecologist at BU. And I live in Boston. I think I could probably get to any of the sites in Eastie, but would prefer to work either at Long Wharf or Pierce Park. I am enthusiastic, detail-oriented, and sleepy.
Oh, perfect. Well, you can get with Ed's caffeine. Monica.
Hi, I'm Monica Goldberg. So I'm actually an engineer for Pfizer up in Andover, but I live in the North End and I'm interested in getting more involved in the area that I'm in. So I would probably want to be at the Long Wharf location. And then 3 things about me: probably outgoing, determined, and outdoorsy.
That's awesome for this project. Perfect. Megan.
Hey everybody, thanks for having me here. So I'm Megan Burns. I work for a company called Indigo Agriculture in Charlestown. I'm just an individual signing up. I used to work with one of your colleagues, Melanie, at the New England Aquarium. So I've been following the company since she started working with you all, and definitely really interested in this topic. So excited to get involved. To describe myself, kind, personable, and love being outdoors, love the environment. And for areas, I do live in Somerville, but for areas probably like Long Wharf, proximity to the aquarium, lots of good memories there. And then East Boston, really just whatever's closer, I suppose, for where I'm coming from.
Awesome. Thank you, Megan. Abby? Is Abby available? Carl?
Hi, everybody. My name is Carl Newman. I'm here as a independent citizen, but at the same time, I'm a history teacher out here in Metro West. And the Long Wharf and the Pierce Point, that side of the Boston is probably going to be more accessible to me. But I'm also, I go down there a lot in terms like the maritime history and the interface of humans and the water there. So that's part of the reason why I'm really interested in this, and geography. Adjectives, definitely an introvert, but I like exploring nature and probably a bit too much bookish.
Awesome. Thank you, Carl.
Yep.
Rutong? Is Rutong Zhu there?
He wrote something in the chat.
Okay. Oh, here. Great. My name is Rutong Zhu. You can call me Elena. Birder. What is INFJ? And introverted. Is that like ENTJ?
Myers-Briggs.
Yeah. I know, all I know is mine, so it's pretty close. And introverted, I'm a freshman at Brandeis in Boston and want to major in biology. Thank you so much, Rutong. And Amy?
Hi there, I'm Amy Kaiser. I'm driving, so I'll keep it quick. I am an independent video artist and a filmmaker, but I also work supporting 2 labs over at MIT as an administrative work, working in clean energy and also pollution. And in my artwork, I do a lot of work on endangered marshes on the East Coast here in Massachusetts. So I've been doing a lot of filming out there and really got hooked on the marshes and walking the marshes and making work and wanting to do more about restoration and also the tidal surges and storm surges. So people would describe me as creatively inspired, hyper organized, and kind. So thanks.
Awesome, Amy. And we can talk more about marshes and filmmaking, video making. That's awesome. Lots to talk
Thank
about.
you.
Thank you.
Thanks. Oh, I'd probably want to work down on Long Wharf.
Awesome. And Abby writes, her name is Abby Sun from Brandeis University, energetic, caring, and optimistic, and want to major in biology as well. So also lots of, we can teach you how to do the intertidal monitoring also while you're down there doing coastal surge investigation. So lots of expertise in the virtual room here. Thank you so much. And also being able to join from a variety of libraries and cars and things. So thank you so much for making the effort here. And we can talk more about the intertidal monitoring. Yes, there are a couple sites that are continuing, and if you have an interest in continuing that, we can keep going there. I'm going to turn it over to Joe. 3 adjectives and who you are and what you do.
Hey everyone, Joe Christo, Managing Director here at the Stone Living Lab. So excited about this project and so happy to see you all here tonight. Thanks for joining. I get to work with Bob and Rebecca, Kirk, and so many others every day. 3 adjectives. I'm going to go with one of Ed's there as caffeinated. I'm also going to go with energetic. And I'll also, I think somebody said outdoorsy. I'll go with outdoorsy too.
Awesome. Thanks, Joe. And we're going to go to Rebecca.
Thanks. So I'm Rebecca Shore. I'm the Education and Engagement Program Manager at the lab, working with all these folks many days as well. And my 3 adjectives would be outgoing. Man, I had another one. It's already gone. Outgoing,
Forgetful?
curious.
No.
Yeah, forgetful. Outgoing, curious, and theatrical.
Whoa.
Theatrically minded.
You can get filmed by Amy. And Kayla?
Yes, my name is Kayla Bradley. I am an undergraduate studying environmental science at UMass Boston. I also work in Bob Chen's lab as a research assistant, and I'm going to be working on this project with the Stone Living Lab. I am very excited. I'm mostly going to be helping everyone with their storm surge measurements and everything. So I'll be going out to your sites with you and stuff like that sometimes. I wrote down my words because I had so much time to think. So I wrote overachieving, friendly, and adventurous.
Oh, that's pretty good. Yeah, I've used those. And Kayla will probably be your main point of contact for everything, and go out to the sites with you and bring an RTK GPS to get accurate vertical and horizontal positioning. And we're going to turn it over to Kirk for you introducing yourself and sharing some thoughts about coastal surge.
Yeah, sure. So I'll give an introduction, then I'll share my screen and we'll try to navigate the wonderful technology world that we're all living in now. So I'm a coastal engineer, actually, with a private consulting company that branched off Woods Hole Oceanographic Institute called the Woods Hole Group. However, I also am a adjunct faculty member at UMass Boston and also heavily involved with the Stone Living Lab. If you want 3 words to describe me, you can guess my first one is going to be lack of sleep. I'll go with a phrase because of all those things I do, I rarely get to sleep, which is why we need your help on this and why I need your help on this so desperately. Second one would be basketball. I'm a huge basketball fan. My kids all play. I coach. I'm heavily involved with that. And a third phrase that's kind of out there and weird is Canaan dogs. So I have 2 pretty rare type of breed dogs that we own and breed called Canaan dogs. And if you don't know what they are, you can look them up. They're the national dog of Israel, actually. They're desert dogs. Don't know how I have them, how I ended up with them, except my daughter wanted dogs. She did a research project, said she wanted a Canaan dog. That's how we ended up with them. So anyway, it's a little bit of background. I'm going to try to share my screen so we go through some stuff here and tell you a little bit about, just give you some background on storm surge, why it's important for what we're doing, and tell you a little bit more about what I'm doing to give you a feel of why we need some help. So hopefully you aren't looking at yourselves anymore. Can someone give me a verbal cue that you can see my screen?
It's still loading, but it says that.
Okay. Just let me know, Kayla, when it's there.
It still hasn't arrived.
It's taking its time.
Yeah. Maybe
really?
try unsharing and resharing.
Okay. It's got an attitude today, huh?
I'll just do some quick reading about the Canaan dog.
I actually Googled it as you were talking. It's so
yeah.
Cool. Nice. Any luck now?
It's still saying you're started sharing. Do you want to send it to me or Rebecca or something?
Maybe. Never had a problem with this ever before.
No.
It's really bizarre.
Oh, there it is.
It came up. Here we go.
We're here.
You see it now?
Yeah. Yeah.
We see your
All
whole
right.
desktop. There we go. Perfect.
Got it? Okay. So just a little bit more background here. Here's a couple of pictures. The top one is from Tinian Beach area. The bottom one is from Morrissey Boulevard, which I'm sure some of you are very familiar with. And so more and more, we're getting these flooding events, even on kind of sunny day type conditions. And just a little bit of background on what storm surge is. It's really basically an abnormal increase in the sea level that's caused by a storm event. So the graphic, I like the graphic on the left here because it really explains what happens, which is you get a big storm event, which consists of wind and pressure changes. And what that does is it pushes the water, 1, towards the shoreline, but 2, down at the same time in that area. And so in an offshore location, you're not going to see, you could be in the middle of the storm, you're not going to see any real change in water level because the ocean's so deep and it doesn't really move things. You'll have waves and a whole bunch of stuff like that. But as you get closer to shore and as that storm approaches shore, it pushes that water towards the shoreline, and then the bottom comes up, right? The bottom of the ocean, and the water can't get pushed down anymore, so it has nowhere else to go but up and inland. And it's caused by both combination of pressure and wind, but as you can see in that diagram right there, vast majority of the surge level increase is caused by wind-driven surge. This is, of course, compounded greatly when you look at the right-hand figure, which shows, sea level going up. So you get your mean sea level, and surge is going to ride on top of that mean sea level. And then as you get higher and higher base water levels, you obviously are going to compound that potential flooding problem going forward. I'm going to skip the next thing just in the to save some time, and also because of kind of the technology things, I don't want to mess with it. But what this is a video from the Weather Channel where they talk about surge. It's a really kind of interesting graphic that they go through. But what he talks about the whole time is storm surge, and he really doesn't get it right. And so I just want to go through some basic definitions of what storm surge really is. And so if you watch the rubber duck there, he goes up and down, and that's a normal tidal condition, right? You go from high tide to low tide. In places like the South, that tide range is pretty low, 2 to 4 feet or something. If you're up here in the Northeast and Boston area, it's a 10-foot tide range. So at low tide, it's 10 feet lower than it would be at high tide on average. Certainly, if you go up into Maine and go any further, that range even it's higher. And so, normally the water goes up and down like that. And if you think about tide range, you look at this lower graphic here, when you have a storm on top of that, right? What we have is this increase, that abnormal increase, which is called storm surge. So that's this difference between, the tide level, which could be at low tide, could be at mean sea level, could be at high tide, or anywhere in between, and then this upper level, which adds the storm surge. The ultimate water level is actually called a storm tide, and people get storm surge and storm tide confused a lot, especially on weather broadcasts, and they'll say the storm surge is 20 feet, right? And what that really is the storm tide, which adds the tide changes to the storm surge. So to put that in a little bit better context for this area, these two figures here basically show the time series of water surface elevation in Boston. These are Winter Storm Grayson, which is in January of 2018, and then Winter Storm Riley, which was in March of 2018. And so the water goes up and down. This is the tide. This is the duck going up and down. He's coming up, he's coming down, right? And this is just normal tidal conditions. And the blue is what is predicted to normally occur. So we know how the sun and the moon and earth all interact, and the tides go up and down, and that's what causes the tides. And they're very deterministic, meaning we can predict what they're going to do because we know how the gravity of the moon and the earth and sun all interact with each other. What we don't know is the green line, which is the non-deterministic or random things that can occur due to pressures and winds, and in this case, a storm or nor'easter, where that water level goes on the green, which is measured in Boston, goes above what we expect to occur, which is the blue, right? And so that storm surge is that difference between the known tides and what we actually see. And so Grayson is on the top, Riley is on the bottom. And so if we kind of subtract those two and you look at the differences, you can actually see these purple lines, which shows the storm surge that actually occurs. And so Grayson happened, was very kind of a quick moving extratropical or nor'easter event, and then kind of went down and actually had a drawdown effect afterwards. Riley was a much longer lasting strong condition. You can see kind of the increased levels that occur over multiple days or multiple tidal cycles. And so the key thing I want to point out here is that purple difference is actually the storm surge. The green level way up here is the storm tide, right? So there's a difference between the actual surge, which is the difference in the tide, which is everything added up to get you to that peak water level. The other thing that's kind of interesting about these two storms now is Grayson itself was a record-setting storm. This was the highest storm tide that we've ever seen in Boston. So that got up to 9.7 feet. but the storm surge really wasn't that big. It was 3.3 feet. So why is our storm tide so high and our storm surge not the biggest thing we've ever seen? Was it that strong of a storm? Well, it just depends on what your normal tides are doing, right? And in that case, in January, we had very high normal tides, spring conditions, meaning the sun and the moon and their orientation of the earth were pulling that water higher and lower than they normally do on average. And so that storm just happened to align very nicely with a very high tide and got you this very high water level. Riley, which didn't get as high, the green only got up to 9.2, but the surge, the actual power that the storm was creating with the pressure and the wind was much higher, it was 4 feet. And just to get it in some further context, the blizzard of 78 actually gets up to 4.5 feet of surge. And so it's really important of especially in the Northeast, how the tides are aligning with the surge to create that ultimate storm tide, which causes flooding. So you're not actually going to be observing storm surge, despite the name of this whole thing. You're actually going to be observing storm tides of various levels. Real quick, some other definitions to think about here are waves. Waves are things that run on top of your still water level, right? So if you look at this graphic up here, you have the still water level here. A wave's going to go above and below that. And a lot of people think, well, waves, we just add the waves to the still water level, and that gives us the height of what the wave would be. Well, no, because the wave really goes above and below that still water level, or that storm tide, if you will. And so the waves crest, which is just, about anywhere from half to 3/4 of the wave height, is really what we are worried about, right? Because this gives you the ultimate highest water surface elevation. There's also things like wave setup, which is basically when a wave breaks, it pushes more water up against the shoreline in this little area here. It's not important that you understand how that works or know what it is, but I just thought you might want to know everything that goes into these water levels. And then there's wave run up, which is when the wave breaks and hits the shoreline, it pushes the water. If you go to the beach and you stand on the beach and you put your feet in the sand, right, a wave will run up and wash over you. Not every wave, but certain waves. That's what wave run up is. And in a storm, you can imagine how it gets larger and larger. And then that leads to wave overtopping, which is shown in this upper picture here in Hull, which is when a big wave hits a structure and or could be a natural land feature and then throws water over the top. All of these things are things we think about when we're talking about flood risk and the effects of storm surge. So why am I talking about this? Why is it so important to observe? Well, it really is surge as the component of the storm, really the greatest threat to life and property that you can have during these passage of events, whether it's a hurricane or an extratropical cyclone or a nor'easter event. And we need data to better improve our forecasting of what's happening, and really need data to better improve our predictive models. So one of the things that we're spending a lot of time here on is modeling these storm events under current and future conditions. And so just a little bit of a background on that. One of the things that I'm heavily involved with is looking at, this is Sandy, by the way, which kind of prompted the whole Northeast and kind of woke up the whole Northeast to like, oh my goodness, what could happen, especially what happened with New York and New Jersey. And so Massachusetts were like, boy, what if it didn't take that left-hand turn quite as early as it did and just kept going? It would have been a really different situation, I think, here in the Northeast. And so we have a need to understand what's at risk, right? Where's this water going to go during these storm events, right? So that we can design potential solutions, adaptations, or think about moving away from certain areas under flood cases. And existing information that was out there was kind of limited. And what I mean by that is you have FEMA maps, which show flooding based on insurance purposes. It's one storm. It looks backwards only at historical storms. It doesn't look forward. You have these national storm surge hazard maps, which are worst case scenarios. It's just looking at hurricanes. Doesn't look at nor'easters or anything else. It's really coarse model, which means it kind of has 1 or 2 points for all of Boston. Errors are really large, and it really isn't based on protecting infrastructure or natural resources. It's really just about human lives. So worst case scenario, how do we get out? How do we, get out of the city? That's really what that is. And then some of you may be familiar with these bathtub approaches to flood risk, which basically say, hey, if mean high water today is 10 and we get 2 feet of sea level rise, and we just say it goes up to 12, or in this case, if we get 5 feet of sea level rise, where does the water go? And it basically just floods an area. And anybody in this call could do this, which is basically like if the land is at elevation 11 and the water goes up to 12, it gets wet. And these bathtub approaches are very reasonable first order, I guess, assessments of flood risk, but they really don't tell you where the water is going to flow or go. It's kind of like if you fill up your bathtub at home, it gets to a certain water level, right? That's great if it's just a really calm day where nothing's going on. But if you have a storm, and if you've been to the coastline during a storm, it's not a flat water surface elevation, right? There's waves, there's water going all over the place. I kind of put it to kind of, I filled the bathtub at home, and then I put my kid in there who's 5, and it's not a flat anymore, right? There's water coming out at me. That's like the coastal storm. I put Hurricane Jackson in the tub, it's all over. Water's coming at me, everything, right? So you can't really use this type of analysis of a bathtub when you start thinking about dynamic conditions. And just an example of that is, here is flooding that would exist if you went up to 12 feet elevation throughout the city of Boston. The yellow, it's all yellow because it's a flat water surface elevation like a bathtub. Here's what gets wet. But if I actually simulate the physical movement of water and things like dams and pumps and elevations and waves and wind, I get a really drastically different picture between that and that, where I get 2 feet higher of water down here because you get winds pushing the waves in that area. And I get protection in certain areas where I might have dams or things of that nature in the city. So, and you get variable depths and elevations. And so we really quickly learned that if we really want to get good at predicting this, we have to better understand the physical movement of water. And so we developed this numerical or computer model that basically looks at really how physically water moves and how it moves under changing climates, and looks at not just hurricanes, not just one storm, it looks at a whole bunch of storms to understand where things are flooding. And it's very high resolution. You may have heard of it. It's the Massachusetts Coast Flood Risk Model. The predecessor was also the Boston Harbor Flood Risk Model. And it really looks at physics-based flow of water. So we're literally at sub-second time levels at resolutions of 10 feet or so, which gives you parcel level information, how the water is flowing through the city. And in this case, the entire state of Massachusetts. And it includes things like dams and pumps and how those all work. We have changing climates in there. So the global climate models introduce changing intensity and frequency of things like hurricanes throughout the evolving time frame that it's in. It's calibrated and validated, which is we're going to get back to, because that's where what the work we're proposing here really comes into play. We really don't have tons of calibration information. I mean, we have gauges out there, like as shown in that picture there, that shows, how our model tracks against what was observed in terms of in the water. But then in overland areas where we're talking about observations, there's really kind of a lack of information in some cases. And then the model is probabilistic. What I mean by that is it's basically we simulate thousands of storms. So we're not just doing one event and saying, here's what this did, right? Because the blizzard of 78 floods things completely different than the storms in 2018, completely different than this past year in December 23, completely different than a smaller storm might do. And so you need to simulate all those to really get your full distribution. This is just an example of what that computer model looks like, just so you guys can see it. This is a tropical cyclone or hurricane that's coming up towards Massachusetts. And the arrows are the wind speeds, and then the colors are the water surface elevation. So you can see how the model replicates surge, right? So when you get those reds and oranges that come into the shoreline, that's the model physics of the water movement, feeling that bottom surface and then pushing the water up against the shoreline, and it then flows overland and causes flooding in the area. We get maps that give you distributions or probabilities of flooding, and then we can look over both space, meaning throughout this area. This is the city of Boston location, and over time. So we can look at how it changes. This is, for example, flood risk in 2030. This is flood risk in 2070. And the darker colors mean you have a higher chance of getting wet in those specific areas. So not surprising, some of the areas we were talking about, South Boston, Long Wharf, East Boston, Moakley Park, Carson Beach, those are the areas where we start to see blues show up, because that's where the flood risk model is predicting that there's going to be flooding. And we see that during, kind of these larger king tides, if you call them that, of today, is that's where you're getting the flooding. And we produce things like water surface elevations and a whole bunch of other data that comes out of this model. But what we really need to do is make sure the model is accurate, right? So like I said, we calibrate it pretty robustly against tides and tidal constituents throughout the entire Atlantic Ocean. Our model basically has to simulate the storms as they approach from the Caribbean or the Gulf of Mexico and all the way up to Massachusetts. We calibrate things like waves. We calibrate to like the water levels that we have, measured out there in the water. And then there's some high watermark information that exists for these big storms. So for example, the blizzard of 78 was a big storm. USGS goes out there, and after the storm, they look for things like ice lines on fences, or observed high water debris on this doorway here, or rack lines. This is from 2018. And so they come up with these observations of, well, that was at elevation 8.44. Now, the problem is this is all happening after the fact, which is, and in some cases it's really clear, like this doorway. And in other cases, it might not be, like cause of flooding uncertain. Or, well, it's really waves and we really don't know what's happening there, right? So these are great data, but there's a lot of kind of uncertainty in them. Here's the stuff they provided from 2018. All those little green dots are areas where they went out and did high watermark observations. A lot of them are in the Boston area. But again, they're somewhat limited because they're not necessarily observing them when they happen, which is where, this project kind of comes in. Because where do we need the help, and why do we need the help, right? We want to improve these predictive models. We want to understand where water is going. And so one big key thing is it's not just big storms, right? So in our model, we're not simulating just the biggest storms, right? We're not worried about just insurance, charging people for insurance, right? We're worried about where your risk is evolving over time. And that includes smaller events. That includes, just normal big tides that might flood areas. So there's not any good data on those cases where we don't have a really big event. We have some of that from USGS for just these big storms that are record-setting storms. But what about, we need information for, like, your storm that might happen every other year, for example. The other thing that we don't have from those high water marks is we don't have observations when the water is present a lot, right? And so I would stress that, we're not telling people to go out there in the middle of the storm and measure where water is. But hey, if you're in an area where you can safely make observations from your building, from your home, from, in a case where it's a sunny day flood condition, you can actually go out there and measure it. That's really, really useful, because we want to see where the water is when it's actually present, and not necessarily rely on after the fact conditions, right? We also really need more spatial coverage, right? So it was great to hear, like, hey, I want to do Long Wharf, I want to do Carson Beach, I could do East Boston, right? That distribution or the extent of the overland flow, we don't always get, right? We get 1 point, usually the Boston Harbor tide gauge that NOAA runs, or maybe 2, right, of what the water is doing. And usually those are always in the water, meaning they're wet all the time anyways, and not overland. And then the last thing is, measurements of how long the flooding lasts, right? So again, we get a mark, we get a high water level, but it's not necessarily how long it stays there. And our model is really looking at the physical flow and passage of the entire storm, so we can get better results if we know how long the water is there, right? We're supporting this, through UMass Boston and others, where we're going to have a couple gauges out there that are measuring what the water level is doing, and we're probably going to put these in areas where most of the time they're doing nothing. And what I mean by that is we're not going to put them in a location where it's wet all the time. We're going to put it, say, on Long Wharf and say, hey, when it does flood in here, it's going to pick up that water, it's going to view it. And so instead of this, signal here, which is going up and down with the tides, it might just see this little orange blip, right? Oh, we saw water here over this critical elevation threshold, and we can measure how long it was wet and how high it got with the digital sensor. We might use satellite data to have a look at the extent. The problem with satellite data is you have to do it when the satellite passes over, right? So you get limited temporal coverage, and you folks can provide much better temporal coverage than maybe the satellite can provide. So we've already mentioned some of the key locations, but here's some of the key locations that I know flood, that you probably know flood on a regular basis. Tinian Beach, we have a project there right now with the city that's looking at resiliency measures there, but you can see that floods. Long Wharf, the aquarium area at floods during normal tidal conditions, up to the aquarium during storm events. East Boston has some areas that flood on a pretty regular basis. And then Morrissey Boulevard, that's a picture of a guy kayaking down Morrissey Boulevard just from this past December 23rd. So it's an area that regularly floods. And now these are just some. There are plenty of others, Carson Beach, that Bayside Expo that we could get data from. So it's not limited to these, but these are some of the key locations. We'll probably have those sensors in a couple of these locations to measure that information. So that's my real quick spiel that hopefully was worthwhile for you to understand what we're doing, how you can be helpful in measuring and observing some of these surge locations.
Kirk, that's awesome. Thank you so much. And if that was quick for some of you, or you want to take a look at that, we'll have the recording posted on the Stone Living Lab website, and you can take a look at that again and use it in your class if you wanted to, or just take a look at some of that information. But we have Kirk here live. So if you have some questions, please don't hesitate to ask by chat, or just shout out or raise your hand, any of that.
I did want to, excuse me. I did want to flag, Ed asked a question and Bob answered it briefly. And I think Kirk, if you have further thoughts on this too, which was, will mitigation strategies worsen impacted areas away from the sites being protected? So for example, if you've seen at a beach, for folks who've gone down the beaches, have seen jetties or those rock groins, it actually worsens erosion at other sites. So is that a concern with storm surge as well?
Yeah, so really, really good question. So absolutely, you're right with coastal structures such as jetties or groins, you'll interrupt the natural transport of sediment. So you might be protecting or furthering accretion on one side and then causing erosion downdrift. This question really is posed more of a redirection of floodwaters, right? So let's say we put a big barrier up somewhere that keeps water from flooding into a location, and then, hey, that water used to go in there, some volume of water, now it's redirected somewhere else. So does potential mitigation of that cause problems? So my answer to that is usually no, and here's why. It depends on where the adaptation is and what the adaptation is. But say you put a big, protective mitigation strategy in some location that stopped water from going into a certain area, right? Would it redirect that water somewhere else? Well, if you're on a big water body like the ocean or Boston Harbor, that volume of water that you redirect back into an area is like less than a drop in a bucket, right? It's so small compared to the ocean that it really can't cause increases of extent or depth of flooding anywhere else. What you have to be careful with is two things. One, if you channelize flow in some way with your mitigative strategy, right? So your strategy protects a certain area, but it redirects water down a pathway or down a street. You can cause increases in velocity and erosion that can be problematic, right? So you have to be very careful in your design. And the other thing I would say is if you go far enough up an estuary or a river where tides go up there and you do have storm surge, in that case is when your volume of your water body that's producing the flooding is smaller, you then can have an effect on the extent and depth of flooding. So say if you went up the Neponset River and blocked off all the marshes in Neponset and didn't let flooding in, on the Boston side. That body of water is much, much smaller than Boston Harbor or the Atlantic Ocean. You keep that volume water out of there, it could very well redirect into Quincy and cause flooding. So yes and no. A vast majority of the locations, the extent and depth of flooding is so minor relative to the water body, it can't cause that problem. But there are cases where you have to look at it.
Other questions that anyone might have? Please don't be shy.
Yeah, I don't bite, and my canine dogs don't either. They warn me, but they're very non-aggressive.
I guess something I'm wondering, Kirk, is, you know, you mentioned that you've been working with the city. So is this, you know, how have you seen different towns and cities either collecting data, using data? Like, how does it seem like everybody's on the same page, or different places are ahead of others? You know, I think that's one of the interesting questions of like, how the coast is all connected, even though we're different cities. How is that coming together?
Yeah, so there's definitely communities, towns, cities that are further ahead than others. So I would say Boston is one of the leading places, not only in the US, but in the world. To be honest with you, they're really, you know, through the whole Climate Ready Boston project, through, you know, the modeling that we initially developed, that basically was the blueprint for how they were going to go through Climate Ready Boston. They've been really proactive and forward thinking with their ability to deal with this. New York isn't that far behind. Places like Seattle have some interesting approaches they've done with living with water. California has some unique things that they're going on. Of course, I would go back to the Netherlands and say they've known about this forever and have been doing things in their way. There's some places in Europe that are there. There's a lot of places, even in Massachusetts, that are just starting to think about it. We're just working on New Hampshire and Maine coming up. You asked about Miami has a big problem. They've definitely been thinking about it. They've got a massive issue with groundwater there too. So they've got a kind of a double problem in their area. And then there's some places that are, like I said, don't even think sea level rise is a thing yet, and are just entering kind of that you know, learning stage of the process.
Great.
And yeah, I can share that presentation.
Yeah, awesome. Yeah, that'd be great to have those slides. I think we can share that out to everyone for, you know, sharing in classrooms or even just perusing. I know when I was learning about how tides work as an adult, it like broke my brain for a while. This stuff is way more complicated, I think, than we realized for a long time in our youthful days. Bob and Kayla, should we kick it over and talk about CSI?
I would like to give a little bit more wait time to see if anybody has any questions. And again, don't be shy at any level.
I also just wanted to call to the question in the chat from Ed. Kirk, could you share the PowerPoint for teachers to use in their classrooms?
Yes, yeah, that's fine. Yep. My wife's a teacher, so if I didn't say that, I'd be in huge trouble. So she teaches science and math and is a marine biologist. So
Again, would love to hear from our participant scientists. Any thoughts, questions, worries, concerns?
About how long would we be doing this for?
We were thinking about through December, and mostly timed around storms, times when we think we're actually going to get an increase in surge.
Okay, just curious.
Any other thoughts, questions, concerns? We'll go over some of the expectations as well.
Do you need any other references? Sorry.
No, go ahead.
Do you need any more people to be referred, or is are we good with this amount?
We would love more people to be involved and more places to be involved. So anyone who's interested, we're happy to maybe have another one of these meetings, or also share this recording and meet them at the shoreline and get them going.
Yeah, yeah, I'll just take a copy and show it to my class, the
Awesome.
presentation. So
Great, thank you.
I was wondering, I have dive friends in the community across like New Hampshire, down to Rhode Island. Is this project just within like the Boston Harbor area, or does it expand outside that range?
I'm going to refer that to Kirk. Is
Yeah, so
information outside of Boston Harbor useful to you?
Absolutely. Anywhere in the state of Massachusetts, for one, is useful. Anywhere in New Hampshire, someone just said Portsmouth, would be awesome. Anywhere in Maine would be awesome. We are currently in the development. So the Massachusetts Coast Flood Risk Model, or MCFRM, which is being used across the state of Massachusetts, which we developed. We are currently developing a similar or very, very similar model for New Hampshire called New Hampshire Coast Flood Risk Model, and for Maine. So any data we get out of New Hampshire and Maine is just as useful.
Any other thoughts, questions?
I know I covered some of that stuff pretty quick. If people are really interested in the Massachusetts Coast Flood Risk Model, there's a training session coming up to know all the ins and outs of that model, including the data that's produced from that model in April and May timeframe. So if people really want to know more, let me know and I can get you hooked up with that situation.
Kirk, is the audience for that for like the science research community and not for lay people, or?
It's open for anybody, in my opinion. It's generally geared towards, there's going to be 3 workshops. The first 2 workshops I think are perfect for community planners, town managers, teachers, lay people. The third workshop is definitely geared more towards the scientific and engineering community of how you then get into some of the complex elements that you get from the model for design purposes. So, you don't have to go to all 3. You could go to what you want, and it's all virtual. They're the 2-hour workshops. Some of it might not be for you. Some of it, covers things kind of similar to what we talked about tonight, like what are these definitions that we use. So it gets more into the data outputs from the model and where you get them and how they can be used, what they are.
Awesome. So thank you so much, Kirk. I'm just going to review what we heard. We heard that what the high extent of the water that we observe in our neighborhoods is a combination of the predicted tide plus the storm surge, called the surge tide. And so that's what we're going to go observe and measure, is the highest levels. And they're the highest, the thing that Kirk is most interested in is the difference between what you measure and what the predicted tide is. And the predicted tide is basically based on a single tide water level logger in downtown Boston. And there's the bathtub flat model, and then Kirk's got an additional predictions around, but we need your measurements to ground truth or water truth that those measurements and say, oh, actually the water's, we observe it here, that's what's actually being interacted with people, but it's not in your model, so we need to know about that. And so there's a variety of ways that we're going to work together to try to measure that high extent and the difference between the predicted tide and the normal tide, and I'll show you some ideas that we've begun to think about. But we want you to become scientists and think about, can you take this or anything else that you can think of? Can we share among us as a community? Science is actually a social process. And can we experiment over the summer with some of these ideas? And then when the big storms come in the winter with the big surge, we'll be ready to capture the extent in a really accurate way, and then report and work with Kirk to make his model better. So that's the idea. And let me just show you that, I've got a couple slides here. Kirk did this very well. You can go, so you can go during the flood and take a picture if it's not dangerous, and that's really a good way to go. If you are staying safe and inside during the high winds and the water, you might find evidence that water was at a higher level, and you can take a picture of it with your phone, and we can take an accurate location with your GPS on your phone, or mark it somehow, with a piece of tape or a pen or something, and we can go at that point or some later time with a very accurate GPS $25,000 instrument that Kayla is going to learn how to use to say exactly, to the centimeter how high that water level mark was at that exact location. You can look at where the stuff that floats washes to the highest level. It's called the rack line, or plastic also floats. And so you can see where the trash goes. And we want to know not just in one transect where it might go to the highest level, but where horizontally is the ring of where the water was during the highest surge tide. So there's other observations that if you go out after a storm, you'll probably see some other things that you can report and say, hey, this was a really good indicator. The grass was bent over, or the leaves moved and were cleared from one area to another, or whatever it happens to be. This is the one tide gauge that we know is in Fort Point Channel. It's run by the National Weather Service and NOAA, and all of the predictions that Kirk talked about in his model is based on is basically this gauge, this single gauge. And we're going to add 2 more as part of this project, and all of your eyes and all of your measurements at all of the storms. So to help with sort of that spatial extent that Kirk was showing, that some areas are higher than others, and some places flood that weren't expected, etc. Here's that it can actually come through storm drains as opposed to just from the ocean, right? It can come up through a pipe that's connected to the ocean into a street that's not connected to the ocean. And it can have a vertical extent, but it can also go into places that you might expect or might want to observe. And I'm going to turn it over to Kayla to talk about, well, we might be able to place some things in before the storm comes to get some indication that water came to that site, like placing a bunch of Easter eggs in a park so that you can see if the water actually washed up against them. So Kayla, do you want to take it from here?
Yeah, thank you. So like Bob said, unfortunately, we're not doing a fun Easter egg hunt as part of this. I mean, maybe we could, but we're thinking of different ways that we could measure the horizontal extent of where water's actually going. So one idea that we have are these Easter eggs, or these PVC eggs, or cages almost, that we put these cobalt chloride test papers in. These test papers are blue when they're dry, and when they come in contact with water or very high humidity, turn white or pink. So they're an indicator of whether or not something is wet with water or not. So we are thinking of different ways that we can use this to determine where the water is going on land. Now, of course, during a storm, you have rain, so we're going to need to protect the cobalt chloride from being hit with the rain, or else we'll have no way of knowing whether it got hit with rain or flood water. So that's why we designed this egg, almost cage-like mechanism that we plan on drilling holes into so that the flood water can flow in, but rainwater will not flow in. And we plan on having you volunteers as well as us go and place these before storms at various locations to tell us whether or not they're getting wet. And from that, we can take those different spots and then look, okay, well, if this spot's getting wet, where's water flowing from there, and what other locations are getting wet from there? And that's how we have thought of looking at the horizontal extent. We've also thought of different methods, such as gulf tees, bunch of different things that can lift it off the ground so that you're not just testing if the ground is wet with rain. But we really want to work with you guys to develop this, as well as the vertical extent indicator. If Bob, you want to go to the next slide.
Yeah, and we have tons of this cobalt chloride paper, and we, as part of your kits and support, we can buy these PVC things and supply them to you. And then if you have another idea that you want to try, we can get that to you as well.
And then for the water level indicator, it's a very similar idea, still using the cobalt chloride strips, but this time it's going to be more of a tall pipe that has holes drilled at various points, and we will asphyxiate this somewhere, probably 3 spots per site, so that it is fixed in the ground at a fixed spot with 0 at the bottom. There's going to be a ruler inside the pipe that has cobalt chloride strips at probably 1/2 inch intervals, so that we can watch as the water rises up. So after the storm, we of course deploy these before the storm, but then after the storm, we go take out the ruler from the pipe and we see which strips were inundated with water and which were not. And that gives us an idea of how high water got. And of course, at the top, it has an elbow PVC piece to again keep out rain.
So does that trigger anybody's thoughts of how we might measure where the water was during the highest extent of the storm? Any other ideas that you might have?
I can imagine sort of like a system where there's like a float that ratchets up as it's buoyant and then doesn't descend. I don't know, I've seen the kid toys that are sort of like that with a
Like
locking
a
mechanism.
a one-way float thing?
Yeah, one-way float. So as the water rises,
Yeah,
although I guess
that would work. Yeah, if we get a ducky on a string and then make it only go one way. If there's a design we can buy, we can try it. But if it's a design we can make it. That's a great idea.
That's a great idea.
Esteban was also thinking of that. That's perfect. This I'll just show you. This is an example of this egg. You just have this pipe and you put a screen on there, put the cobalt chloride on top, and then you just stick it in there and you drop it on the ground. And then you go back after the storm, and if it's white, water hit it, and if it wasn't, then it wasn't there. So it's like a rack line, but you've put it in place. So you might do a transect up a hill, or you might put them in a variety of places that you're interested to see if it flooded or not. Other ideas? Anybody else have another idea?
Not an idea, but just going to ask, how many of those eggs, like the PVC pipes, would you place in one site?
Whatever you want, but we can imagine giving you a dozen of these to place out, and then you go back and you go look and go, oh, no. You take a picture of each one as you pick them up afterwards and go, that one was negative, that one's positive, that was negative, whatever. So probably not 1,000, but something like a dozen is reasonable. Yeah. And you might know the site after the first couple times you've gone out. This probably, and now I'm looking at the tide and this was really high, so that's definitely gonna hit, or whatever.
Carl, you have your hand up.
Yeah, mine's more a question about logistics, right? Because are y'all planning to deploy these things right before a storm? Because I just wonder how, like in places like Long Wharf, people are going to mess with stuff, right? Because it's a city, and and plus the idea of it's not criticism, but I'm just trying to think through it. Like putting stuff out, people are going to play with it, right? Because it's like, what's this egg here? I mean, especially those Easter eggs. I'm like, I would play with them maybe. Honestly, it's like, because it's like, why are there these Easter eggs on this beach? So is it going to be something where like we see a storm coming, we put it out, and then retrieve them? Or I'm just curious about that, because again, that just seems like it's something that's going to get messed with.
It's great thinking, and that's exactly how we're thinking as well, right? So put it out when we see a prediction of a storm coming. You put it out a day or two in advance. If you put them out and they're all gone, then we got to think of something different, right? And then we go back a day after, whatever, and we get these things. One of the reasons we could do clear or we could do white, we were thinking clear with a little test strip in it would be really curious, and people would want to pick those up and screw around with those. But these maybe look a little less innocuous. But also, where do we hide these things that is in a place that we are thinking about flooding, that's not something that would be vandalized or interfered with? These are all fantastic thoughts, and I think by playing around at the location and observing and and doing this kind of thing, we'll know better what's going to work and what's not going to work.
Bob, are these tethered to the ground? Because I imagine if there's a flood, wouldn't they be just like displaced, so they could be pushed up in the water?
Another great question. This thing weighs a little bit, so a little bit of water is not going to do it, but a huge thing would wash it away. And so we can imagine drilling it and tethering it in a way. Yeah, absolutely. Lots of different ideas that we can play with. I'll just show you the other one. This you know, is a pipe with the holes in it, and you stick the ruler sort of in the bottom, but you can tie wrap that to I think this looks pretty innocuous, but I don't know, I'm not a passerby, you know, to a stop sign post or a fence post or something that we could do. We have the YouTube, so it'll vent so the water can enter and hit those cobalt test strips. But just, you know, really simple kind of ideas that we thought of, but we can make all kinds of stuff that you guys think of as well. Any other ideas?
I'm hoping I'm not coming across like a paranoid person here, but I'm just wondering, a place like Long Wharf where there's all these public vehicles, right? There's ferries and stuff like that, whether or not like these random objects like this are going to be worrisome to other people, like authorities, like, you know, the people, you know, especially pipes and things like that, you know, that might be an object of like see something, say something kind of thing. And I'm just wondering what's the process of talking to other people, let them know like, hey, you know, we're doing this. This isn't like sabotage or other things, especially because, again, as I said, like the Long Wharf area there's all the harbor ferries and all the boats that go out the islands and stuff like that.
That's awesome. Thank you, Carl. And that's great thinking. Yeah, we have a lot of partners down there that we know, and we would inform them all of what we're up to and show them that it's harmless. We've debated, and we can experiment with putting a sign of what these things are and why they're there. But we're also thinking that with a sign there, it's going to cause more attention. So it's a little bit of a, you know, a little of this and a little of that. But we certainly will inform our partners down there about what's going on.
Yeah, and I think, Bob, also the spot at Long Wharf that really floods dramatically in this way in this picture is not the active ferry part of Long Wharf. So this is actually a separate area where like you I'm trying to imagine, like, if you were standing looking at the boats, you would walk past the Marriott all the way past the restaurant to the end, where there's kind of that small pavilion. So it is still a pedestrian trafficked area, and there's not like boats actively docking and things like that. So that's one slight adjustment. And yes, like we know the folks at the city and BPDA that we could talk to.
Yeah, so I will say, Carl, it's a really good point. Like, so one of those gauges I showed you, which is not necessarily the cheapest thing in the world, and you know, scientific equipment, is going to go on Long Wharf. And so we thought really hard and long about that would be like, certainly we're going to work directly with the city to let them know it's there, everybody there, know it's there. We're actually mounting it up high on one of the light poles in the area, so it's out of reach, frankly, of people, and it is still going to do its job. It just needs to see the water. So I think it's a valid concern, and I think how this gets done is you know, pretty important. I will say simple things like pictures, observations are also really key. So like if you can get there multiple times during a passage of a mild storm, right? I'm not, you know, saying like we you know, the really big storms, winter storms, we kind of have those nailed, to be honest with you. It's really more the like, hey, Long Wharf flooded, and you know what happened during that little event there. And so, you know, even, you know, post storm, you know, I was out there, I took pictures. Let me go look now and see where that mark was on the building, based on my views from before. Those are useful. Those type of things are useful too. In addition to these, I think, you know, you're going to know predictably when these high tide events are going to come. We don't have good data on these high tide events overland, right? So it's going to be safe to go out there just before the high tide event, put these things in place, hide them behind a garbage can, whatever. And I think we'll get some pretty good information.
And so keep thinking like that, because that's the kind of ideas that we need to work out as we start experimenting over the summer here. the other supports that we can provide. Kayla, do you want to talk about this stuff?
Yes. So this is the survey 123. Essentially, this is an online data sheet that will be provided to all of you, where instead of having a physical data sheet that you bring out with you, which I think I'm also going to create a physical data sheet just for those of you who prefer to like physically write it out while you're there. But you just open up the form and it's essentially just like a Google form, but has more capabilities. So as you can see, you can put down actual points on the map with GPS coordinates of where your spots are for your cobalt chloride markers. And you can also put in photos too. So photos of your sites and of your water lines and anything that you find.
So you just do this right on your phone.
Yeah, there's an app for it. There's a desktop version. So it's super simple and super easy for data collection.
And it collects location automatically?
I am not sure. I believe it does, but I know that you can also add the location manually. And you can find the location from your phone's GPS.
So as Kirk was showing, we want to get, you know, a variety of sites. And so we will be working with you to figure out, you know, if we all went to Long Wharf all the time, we'd get a lot of duplicate data, which could be good. But we also want to spread across a variety of sites that might also be accessible. So let's see, who wants to talk about any of these sites?
Well, yeah, I think Kirk named some of these sites, and even I know in the survey that we sent out, some of you all checked off these sites or have other ideas in mind. I mean, really, these sites are kind of a combination of places we know are already flooding, and then also some places that are points of interest as sort of gateways to other areas. And like Bob had mentioned earlier, with the idea that storm drains flood, for example, we know in Central Square in Eastie, there's a parking lot that floods often where it's overtopped, and there's also a storm drain in that parking lot where the floodwaters sometimes only come up through that area. So this is in no way an exhaustive list. So if there's a place that jumps out to you, and I know several of you named some of these sites already, and there's other spots that we're happy to hear more about, because we're not everywhere, as Kirk was saying. Like they don't have the, you know, local knowledge of walking the streets every day and seeing where the flooding's happening.
So if you have an interesting site that you think floods or knows floods, or you have other friends in some of these areas, this sort of gives you a sense of the distribution that that would be great to match Kirk's sort of distribution of his model, right? We need to ground truth it across as much of Boston Harbor as we can.
Yeah, good point. Can you just go back there? Carl pointed out 10 and 11 are two sites that aren't actually on our map as potential points of interest too. I'm trying to remember which ones those are.
10 is Tinian Beach. I know that.
Yeah.
Indian Beach is a real flooder. That's a good one.
Yeah. 9 is probably Savin Hill Cove, which is our Boulevard area.
And then Levinson, Williston, Quincy Bay.
Is that Wallaston, number 11?
Yeah, I believe so.
Yeah, that looks like Wallaston. And it's, you know, 7 Carson Beach, but also the location of what do they call it? What do they call Bay City is going to be developed, and it would be good to know where they have to put it to protect. Right. So I'm gonna you know, we'll do this more as we get closer, but if you just check the weather.com and see when the storms are coming, that gives you a heads up of like, oh, I want to get my eggs ready to go out, or whatever it happens to be. These websites give you the tides and the predicted tides and the predicted surge. So then you can get ready for the storm, check for signs, you know, put your things out, go recover them, check for signs of water, take pictures, sort of all that stuff during, before, after the storms. And then I don't know, I think this is on the story map. Do you want to share the story map, Kayla? or do you want me to share the story map?
If you could, because I still don't have screen sharing on this.
So what did I do with it? Okay, is it in the chat?
No, but I can get it in the
You have
chat.
it, Rebecca?
I've got it. It's coming into the chat. And thanks, folks, for putting in the Zoom chat as well, where what locations. Esteban, good question about Constitution Beach. I think I'm not familiar that beach floods up to like the walkway. You know, I know the high tide can get pretty high, and that's an interesting spot too because there's the T right behind it. I don't know if others, is anyone familiar with Constitution Beach?
It doesn't flood
It doesn't?
currently.
That's
No.
Is it? Do you think it's because it's that protective little cove there?
It's part of it, but it's also
Mhm.
just higher beach elevation than a lot of places.
It's a major, as Kirk will tell you though, it's a major flood pathway for the future,
future,
with sea level rise, but not flooding quite yet.
So awesome. Kayla has put together this story map, which she will update as data comes in. It talks about so the chat has the link. You can look at it now. There's a project overview about simple stuff about coastal storm surges. You know, next to this, we'll post Kirk's PowerPoint and his recording and everything. And then this idea about, you know, let's look at the forecast 10 day out, just simple weather. And then thinking about, is it really happening 3 days out? We get pretty accurate of when it's going to happen in Boston, and then you know, put it out a day before and pick it up after the storm, this kind of thing. And there's, we're gonna, when the sites, you know, actually are start monitoring, we're gonna stick them in there, and we'll begin to put the data in there as well in this story map. So we have like 3 minutes left. I really appreciate your time. Any other questions, thoughts, concerns?
Do we
I
need
guess, sorry.
Go ahead.
I was just going to ask, you know, understood that it's dependent on when storms come, but when do you anticipate that we would be like getting out into the field?
So next steps, great question. Kayla, you are going to start, you have times to meet people in places?
I've marked a couple days this month where tides will be high that I could come meet people at certain points, whether that be I know a lot of people are interested in Long Wharf, so that could be it, or near Morrissey, near UMass Boston, and we could do just some preliminary playing around with the cobalt chloride and the eggs and everything, as well as some just training on how to take water levels and everything like that.
So Kayla will be emailing you all the times and locations, any of the resources, the what do you call it? Or the instructions for the getting survey 123 and the handout paper copies of the data sheets. Anything else? What else? You'll be hearing from Kayla basically is the next step.
Thanks.
Those dates are in the next week or two, Kayla?
Yes, they are in like next week and the week after.
Oh, whoa, they're the dates. Look at those things.
Yes, just slapped those in. So yeah, it's mid to late March. And of course, part of what we have to deal with is that making sure the high tides are falling during the daytime, because they don't always do that. So that's why we have to do a little bit of future predicting.
And I will also just say I am unavailable March 25th. I forgot to put that down, but if someone else could go out, or we could just do a different weekend training day as well.
I did just post the predictive site we use for water levels. It's gotten buried quickly into the chat, but Bob and Rebecca and Kayla, you might want to grab that one.
Yeah, and we can share all of these sites and links and everything else.
Yeah, that provides predictions about 3 days out in advance. It's a little bit, it's different than the tides and currents, which is just, tides and currents is just deterministic. This site is, you know, storm and weather based. It's not perfect, which is why we want to do a model there, but it's better than the tides and currents one.
Bookmarking that immediately. Ed, I saw your question. So I think Kayla's gonna reach out, everyone got inundated with a lot of information today. Kayla, I think, will reach out in terms of coordinating some dates and some different locations. So it does sound like Long Wharf is accessible for a lot of folks, but we could do, a little bit further south, a little bit further north. So this is kind of the period where we get to have some flexibility and sort of meet everyone where they're at. So we'll do some, surveying and make sure that everyone's, we'll figure out in terms of like, where is it parking? Is it tea? Things like that. And Carl, saw your question about committing to the entire length of the project. Obviously, we would love as long as folks are able. And, if you're able to give us notice of, hey, I'm going to be on vacation for 2 months, or I'm actually moving out of the country in October, just keeping us informed, and we'll make sure that different folks are able to pick up different sites. But really, this is a space where we want you all to be as involved as you want to be. And truly, as Bob was framing earlier, like we're trying this out. And one of the nice things with leading into the spring and summer is we'll have lots of nicer weather, hopefully, to play with and figure out the protocol. And then especially leading back into the fall and winter of next year, that's when storms get really exciting. And hopefully by then we'll be like a well-oiled machine and really be able to collect some cool data. So Carl, just stay in communication with us and we can really figure something out.
Thank you all so much for your time this evening and your interest in this project. I think it's really going to be a lot of fun. We can play around with some things, experiment with some things, and really see that our information and our data is feeding Kirk's, as I said, water truthing Kirk's model, and is really going to help the people in and around Boston Harbor with better predictions of flooding. So thank you so much, and we'll be in touch soon. Take care,
Thanks, everyone.
Thank you. Have